Welcome to AB Shop. In this first video I want to show you my first project. It will be very simple. It will be a nut, something like this, for my milling machine, and I will show you how to make this special nut. So I hope that you will enjoy my video, and let me show you what I want to do. Okay, so in this first video I want to show you something very simple, and the project is to remake this handle. This handle is used to brake, like a brake, to stop the X-axis, and you have to stop sometimes the X-axis. Why? When you want to work, for example, with the Y-axis, you have to stop the X to work only with the Y. When you go with the tool inside the material, there is the possibility that the clockwise rotation of the spindle move a little. You can see a little, it can be also 1 millimeter or also more, in the direction of right, so you have to stop. And the other solution to have a brake is when you use the motor to work with the X-axis. If, for example, the minimum velocity is too high, you can use something like this to have a brake, so to go slowly. But why I have to remake this? Is not broke. No, it's not broke, but when the handle is near the vise, I cannot close, because you can see that the distance from here to here is they are very near, okay? So I want to make something round that can close with the handle, something round with the external surface with a knurling. Sorry for my English, that is horrible. And also smaller, that can use only by hand. This is my small project. So the first to do is to find the tape of this screw and the depth of the screw inside. The screw go to the gips of the table and push the gips to stop, to break the table. Okay, so we have to remake this handle. We will start from a round bar of 20 millimeters, and we go with a small project, with this small project, and making by lathe, with my lathe. Okay, let me show you how I can do this small project. Okay, this is my small project. You can see it's very simple. There is a round bar, a cylinder that is work here with a screw that is M6. In particular, we will have to check the length of the screw to find if it's enough to go to touch the gips, and also we have to check the 30 millimeters that is not much, or it's more that I need. So we have also to check if this dimension is okay or is too big. To do this, we have to unscrew the handle, and it's very simple. There is only, sorry, because it's magnetic, there is some chips, and there is a screw, very simple, and also a spring that is for an anti-rotation and no rotation. And okay, we have to check how of this screw is inside, and to check this. Okay, this is okay. You can see also that in the point of the screw is there is something that is not screw. Why? Because when you push, if you use the screw, there can be the possibility that the diameter became high with a slow deformation, so you cannot unscrew. This is the reason why there is this small cylinder made with the lathe, to prevent this problem. Okay, and this is the length. Okay, so we take a caliper, and okay, more or less is the part of the screw that didn't have the chips. So we are around 20 millimeters. So we check if it's enough. And here, as you can see, we have something around 12 millimeters. So it's not enough. The 12 we have to modify to 20 or near 20. Okay. Now we have to check also this dimension. Okay. This dimension is the 13 minus 14. Okay. So here we can show, okay, 6 to 20 and 16. Yes, there is no problem, because we are at 13. There is enough space between. Okay, so we have the space to make this very simple part. And before to start the project, maybe somebody can ask about why you don't move the device, and so you will not have problem with the handle. Oh, it's very simple. I decided to fix the device in this position, because in that position usually I put the dividing head. So I want the space to install the dividing head. Okay, so I don't want to move this. So I have to replace this small handle. This is a piece of wood, as you can see, with also some chips that I use to prevent the chips that are rolling down in my table. Is a piece of wood with a piece of carton, and here there is some glue. Okay, it's very simple, and it's something like this. You put and close, so you don't destroy the table. Okay, so now we have to make the 0 in the x-axis and the y-axis. Oh, sorry, the y-axis in the x-axis, sorry, and the y-axis is the inverse of the milling machine. So to make the 0 here, we make with the tools and we touch. After, we have to go to the DIO and say to the y-axis that is 0. Okay, and now we return to the x-axis, so the radial axis, and in this case we touch the radial. Okay, so okay, in this moment we are touching the external surface. Okay, we have to say to the DRO that the diameter is 20 millimeters. Okay, so we go to the DRO, and to the x-axis, that is the radial axis, we will write minus 20 and enter. Why minus 20? Because if I put minus 20, you can see when I go to the center, the dimension is minus and arrive to the 0 in the center. And when I go down, okay, he return in the 20 millimeters. Okay, so in particular, here you can see that there is a D, because when you program the DRO, you say that you have to write that the x-axis is the diameter. So what you read in this point, in this line, the x-axis is always the actual diameter. Okay, so we return to 20 millimeters, that is the start point, and we start to work. Okay. Okay, so first of all we're facing Okay. We remake the 0 in the 0, and okay, and now we start in the radial. Okay, so we go at 19 and 17. For 22, we make some oil. Okay, and we go. Now we go to 16. This is 19. I'm using by hand. Okay, now we have 7 millimeters. And we have to go down to 5.8, 5.7 to make the M6. So we go. When the diameter became smaller than small, that's like in this moment, you have to cut a very small amount of material every cut, because there is the possibility that the barrel can bend if you cut too much material. So we will cut 0.2, maximum 0.3 millimeters for every passage from 7 to 6 millimeters. Okay. We are at 6.8, 6.6. Okay, 6.4. Okay, 6.3. You can see that the part rotation is very nice. There is no bending. Okay, and 6.1. Okay. And now, with the automatic feed, you make 5.9. This is 5.9. Very slowly. You can see that the surface became nice. And the last cut, 5.8. This is 5.8 for M6. Okay, we measure, stop and measure. 5.91 and the DRO wide 5.89, so it's okay. So now we can cut at a 45 degree in this point. So change the turret and this is the tool. Okay. Very near. This is the inlet for the screw. Very slowly. Okay, and now we make the clearance for the screw with the parting tools. This is the parting tools. Okay. Okay, so down. Start here, more or less. Okay, it's 2 millimeters. Okay. Okay, now we use this one. This is the tools that sometime I use. You can see M6 to cut screw. So we put in the tailstock. Okay. And we can do by hand. Okay, you can make also with the lathe, but also if the dimension is small, we stop the lathe to be sure that there is no problem. Stop, go, and try by hand. Sorry, the protection didn't want to stay in the position. Yes, it's going. Okay, I put some. This is for my hand. Okay, I hope that you are seeing something. It's a long screw, eh? Usually it's not so long because it's 20 millimeters. Okay, I can show you that you can make also by hand when Okay. Okay, and now I show you the M6. Completely formed. I say you that 20 millimeters. Oh, is disassembly from. Okay, not a problem. Okay, yeah, this is a good M6. Okay, so now we are ready for cooling. So we'll make in the center. It's okay. So we go on the right and on the left. Okay, attention, and we close a little on the right and on the left. Okay, we close a little on attention on the right and on the left. Close on the right and on the left, and we stop to see. Oh, I think that it's okay. Touch just a little bit. Okay, tension on the right and on the left. On the right, on the left, on the right, on the left, close a little, right, left, right, left, we touch, so we can go down to see. Yes, from my point of view it's okay, but we can go. No. Okay. Okay, we try to close a little. You can hear the knurling. Right and left. Okay. I think that it's okay. So we open, we go down, we touch. Yes, it's okay. The grip, it's okay, I mean. Okay, so now we have to go with the parting tools. Okay, so we disassemble this one. That is always ready. Okay, we go here. Okay, I switch off the DRO. You hear beep beep, something like this. So we go here and here. We are very down, so we go in the center. It's very important to go in the center with the party tools. That now is in the center, and now we can cut, and to cut is better to stay near the chuck, and so okay, this is okay. Okay, we go here, we say 0. Okay, we have to go to the drawing, and the drawing said 13, so we give 2 millimeters, that is the thickness. Another way 0, and now we move of 13, and this is 13. Okay, we can go also 32, there's no difference, I think. Okay, we try to cut. When we cut, it's better to make the dimension more, because the chips can rolling down better, I mean. So when you cut in the deep, you have also to make something large, more large than the thickness of the tools. Okay, this is only for parting tools. Okay, the velocity have to be more, because we are going to the center where the velocity is 0, so the velocity have to be more and more from the outside to inside, like this. And the cutting tool is okay, is in the center, is cutting good, and we go. I didn't put oil, because if I put oil, they start to didn't cut. I don't know why, so I didn't put oil. Okay, yeah. You can see some chips. Yeah. So we enlarge. Okay. Enlarge. Okay. We go down. Okay, before finish, we can make also this one, because otherwise after can be difficult too. And now I show you what I want to do. So we go here. Okay. Okay. And also we go in the other side near the parting tool. Okay. Because after it's difficult to make this one when the part is finished, so we can go now. The diameter is around 10 millimeters, so they resist also to the pressure. Okay, it's enough, and we stop, and we change to the parting tools. Okay. You can see that with the quick change is very easy to change the tools and also to make something in the velocity. So we restart. Okay. Okay. Okay, we are near to the center. It is the most delicate point. So here you can brake because the velocity of cutting function is like 0. So it's very delicate. I think that we can move with the end, maybe better, because I don't have enough force. Okay, 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 okay. Not okay, but okay. I was thinking that was easy, but it's not. As you can see, it's I think that is 2 millimeters or something like this, not more, but it's not easy. It's something not to do, but I was thinking that it was 1 millimeters, and in fact it's 3. You can see that 3 millimeters is like a pillar. It didn't want, oh okay, didn't want to break. Oh. Okay, brake is very near to the end. Okay, okay, so something cleaning, okay, from chips. Now we have to close, not with high force because there is the cooling surface, you know. Okay. I think that is okay. So we can use a file like this one, and after when we arrive to the surface, okay, we can use a tools. Yeah, of course. Okay, this one. Oh, sorry. Close. it's okay. Yeah. Oh, okay. More or less, we have finished. It's possible to make also a better surface. I don't know if it's in focus or not. Okay, this is the simple nut that we have made with my fantastic bantam. And now we go to see if it's okay or not. Okay, here we go. Okay, I have disassembled the handle, okay, the original handle, and this is our very simple project. And so there is this is the truth moment. I think that is this one, the translation from the Italian. So we go to see if we have worked well or not. So this is the hole that is screw in M6. Oh, and this is okay. And now we have to see if it touch or not before finish the screw. Yeah. It's okay. I don't know if you see, but he stopped before. I think that is 2 or 3 millimeters before. It's perfect. So now we can try to close and to see. Okay, so this is the handle. Wow, it's closed. And so we open, and now I want to see what is the problem. You can see that by hand I'm moving the table, the 6 axis, and so now the nut is under the vise. Okay, for example, I'm working this position, I have to close, and as you can see there is no space for handle, but there is a space for nut. And so close. Yeah. Okay. It's okay. It's worked very well. Okay. Now it's open. You push on the gips, as I said before, and it's a good result. So, okay, it's a very simple nut. This is my first video, so I want to show you something simple. And this is the results. Okay, knurling is perfect. I'm very happy. And now I put this on a side, and I use this one. It's perfect because it works also under the vise. Yeah. Okay, I hope you enjoyed my video and you enjoy these simple parts. Okay.